everyone. I've just come off doing the last one, the social network case, and figured we'd just jump straight into this next one, which was, I think this is the afternoon session 2, so 64 in session 2. Let's set up this timer here, and we're just going to jump straight into this one and see how we go, seeing as we're already on a roll, in the mood. So let's get going. You are communicating in the classroom with your friends by passing notes. Your teacher has intercepted a note in which you confess to cheating on geography. The basic idea is to offset a certain number of letters. For an A, offset 10 places as a K. Z becomes an A. Capitals stay capitals. Non-letters are unaffected. Things get more difficult as you go. Oh, this is the answers. Let's hide that, and let's hide column F. Okay, and we've got 3 bonuses this time. How many capital letters are in a level 3 codes? How many non-letter characters, including spaces, in a level 5 codes? And the answers to 1 to 10 of level 2 code for a certain English word, but you don't know the delta. What's the delta? Is the delta the offset? Yeah. Test your understanding of given letters and shift them. Okay. Codes. I can never remember these. It's 26 letters, aren't there? Yeah, 26 letters. Okay. So that's our ranges for capitals, that's our ranges for lowers. Let's have a look at the questions. So that's just a simple shift. This is a word with a shift. This is a sentence with a shift and capital letters, spaces. This is doing something funny with the deltas, but one word and then as a sentence. Okay. Okay. So the nice simple way of doing this, if that's our delta, let's just do the simple one and get our head around it, because I'm not entirely sure I'm following what we're doing. So we'll use Unicode. So Unicode gives us the code number for this, and then we'll take away 97, because 97, so 0 then is our first letter, and then we're going to add our delta to that. And we're going to need to wrap this in a mod 26, and then we're going to need to add 97 back to it, and then we're going to need to change it back into a letter. The shift has already been done, so we need to do that. Nope, I need to do that. Okay, that doesn't feel the most efficient, but let's just whack that in there. So now we need to split these letters out. So we're going to let S be a sequence based on the length of that, and then we're going to do a sequence of using mid, starting from S minus 1, going 1 character, starting from S, going for one character. Okay, there we go. And that will give us our words split out, so that's good. It's a good start. Should probably be doing this as a model. So let's just pivot to that. And let's just get our little function in. There we go. Okay. So our delta in this case is in column G. I want to turn this into a lambda function, don't I? So letter code delta. I'll call it delta because delta is its own thing. The letter code is going to be the unicode of letter. His letter is going to be okay. Okay, let me talk you through what we're doing here. So, we're going to use a lambda function, which basically lets us put it into a named range and just reuse it over and over and over again, only changing it once, which will be useful later on. We're taking in a letter, we're taking in a delta value, and we're going to let the code be the code of letter. We're checking if it is a letter by making sure that the code is between one of these two ranges. We're going to check if it's a capital. Okay. And then simply if it's not a letter, then we're just going to let it be itself. If it is a letter, then it's going to be the unichar of if it is capital. I'll come back to that. But we've done the if not's capital. If it's not a capital, then it's the code -97 minus delta plus 26, because I can't remember whether this handles negative mods, which way it handles negative mods. Different programming languages handle it different ways. They shouldn't, but they do. Plus 97 and 1. And then these are just 65 in here. And that's just going to give us an error because we've not actually passed it anything, I think. So we'll give it a letter and a delta, and it's still shouting at me. So what have I done wrong? I've missed a B in the word lambda. Okay, right. Is that working for all of them? Yeah, perfect. Okay. So I'm going to take this. I'm going to go to our name manager, get letter, and that's this. I didn't lock that. There we go. See, this makes it nice and easy. So now we can just do this. Sherlockian. And then we're going to texture on it based on a blank. Ignoring empty cells. And let's just pull this all the way over here in case it's a super long thing. We've got 20 questions starting at 3. We all know how to do what if analysis now. Every time. Value. Think that's long enough? I hope that's long enough. Effort. Okay, well, this one then is now a sentence, but that's not a problem. That takes that. They've done that just to throw us off, I'm sure. There we go. There's that. I don't like the spelling of that first one, but we'll run with it. Now it's delta times by the position. That's fine though, because we can just do a sequence of length of this times by the delta, and then unlock this and put it there. Oh, this is well easy. This cannot have been their case. 15 minutes to go, and I think we're basically finished. So that's this, remembering that they messed things around. And then it's 130 to 151. These are some weird words. Do we believe those are the words? Listen. Light is a word. Some of these words I don't know. Woebegone. Erstwhile. Panoply. Is that a word? Can we Google panoply? And now I'm getting a little bit nervous about this because it seems too easy. But it might just be I found a thing that works. Ah, see, no, see that doesn't look right. Okay. So that's that. What was that? Is letter test. There we go. There's the difficult bit. That's the is letter, and if it is letter, then it is that plus that. Otherwise it is just the previous one. There we go. Fool. Where's the purple one? There. Okay. It was doing well until, let's set that to 2. To 3. Right, holler at his crimes. There we go. Oh, they're all right as well. Oh, okay. How many capital levels are in level 3? What was my? There we go. That's my. Is it a capital letter? So not including the bonus. Okay. At the example even. Okie dokie. Let's split that out into its parts. So that's every letter. In there. And then I need to know is capital, but we don't even need that, so it's just those. Looks like it's behaving itself. Cool. And then we just want the sum of those. 39. Non-letter characters in level 5. Cool, it's not run out of space. Good to know. And we can trap that whole thing in a knot. Might be able to explain all this as well before the time's up. Oh, I hope I don't get one of this. This seems way too suspiciously easy. 5 to 6. The answers to question 1 to 10. Are a level 2 code, but you don't know the delta. Okay, that's easy enough. So let's have a delta as 1. Get letter. There's the letter. There's the delta. Join them together. And there are 26 letters in the alphabet, so the delta is not going to be anything too far off that. Data, what if, data table, delta. Are any of these words? Haha, elementary. My dear Watson. Oh, 1135. So that's not elementary? No, it is elementary. Ah, that one's wrong then. True, true. Does that have all of them? Level 5 codes. C caps. Ah, see, that looks right. But I have joined them with a space. .497. There we go. Okay, so I wouldn't have known that, so I would have got 11050. I don't know who did that one and who didn't, so I think it's the afternoon session did this one. So that, yeah. Oh, that would have been a very good score. I feel... Jared there, just, yeah, of course he did. Well, I guess if you know this, and you know how modular arithmetic works, this becomes a lot easier. So let's just walk through it. I've got 4 minutes left of the time. So we started by building it out manually, just to check we're understanding how it was working. So we use Unicode to get the code from it. First of all, actually, we built this, so I can remember Unicode in my head. At a push, I always remember that capital A is 65, but after that I get lost. This Unicode basically tells you what code it is from there, and unichar just changes it back again. Whoops. Just changes it back again. Nice and easy. So we've used that, and we've used some modular arithmetic. So we get the Unicode from this. We take away 97, just to make it nice and easy. We then take away our delta. We then add 97 back on, and we turn that into a code. Nice and simple. And then we built this lambda, and this is what helped us smash through everything. So what lambda does, it lets you basically build a function and then define what its inputs are as if you were writing code, and then pass it different inputs. The benefit to that is you can then save this lambda, as we did, under name manager. So we saved it as getLetter, so every time we use equals getLetter we're calling this, and then we can just give it in brackets what its arguments are after that. So it takes 2 arguments, a letter and a code and a delta. So a letter and a delta, sorry, wrong way around, a letter and a delta. And then let is very similar to lambda. It lets you define things as you go. So we're defining a keyword code. So we've now got 3 keywords: letter, which is the letter you pass into it; delta, which is the delta you pass into it; and code, which is defined by this. So it's just the Unicode version of the letter. So that is this step. We then check if it is a letter, because we looked ahead and we saw that it's only the capital spaces, the capital letters and the lowercase letters that matter. Then we checked if it's a capital, because capital stayed capitals and lowercase stayed lowercase. So this just says, is the code between 97 and 122, or is it between 65 and 90? And then is capital just, is it between 65 and 90? If it's not a letter, we just return itself, it doesn't change. If it is a letter, then it's the unichar, so taking a code, turning it back into a letter, of, if it's a capital, the code minus 65, because it's a capital letter, minus the delta, plus 26, because I can never remember how modulus works in negative numbers. I mean, I can remember how it works in negative numbers, but modulus for negative numbers doesn't always behave the same in every language, depending on how it's been coded up, which is very annoying. But what modulus is it's like looking at a clock face. So when you get to 12, you go back to 1 again. So we all know that 3 o'clock plus 15 hours is 6 o'clock, because you only worry about the add 3, you don't worry about the add 12. And that's how modulus works. So this means that every time it reaches a multiple of 26, it's going to go down to 0. To be honest, I don't think we needed this plus 26. I don't think it did any favours considering how big this delta got. So we're a little bit lucky in that regard. And then we just add 65 back on again, and then the same thing again for the lower cases, but with 97. We then built this function, which just splits out the word 1 character at a time. Built this up, which works out if this is a letter or not, and if not, if it is, then it increases the delta for the later cases. And that's all there was to it, really. And then the bonuses, we just use that if it's a capital, we use that if it's not a character thing, remembering that we can't join with a non-character in that case, because that was silly. There we go, there's the timer going. And then for this last one, we just didn't know the delta, so we built it out with all the possible deltas and just manually went through this list until we found a word that looked like a word was there, and delta 18, elementary. That was a fun little case. I guess the reason it was so hard is most people don't know about these unicode, unichar things, or aren't happy with modulus operators, because these scores are a lot lower in general. And I guess if you didn't know that, you would be stuck, because you'd be then trying to build out what different deltas are and what different letters go to, and that would take forever. But yeah, no, happy with that. That's a good little case. Alright, there we go.